In today's tutorial, we're going to create a puddle shader. For the last several weeks, we've been creating shaders that simulate the appearance of weather, of rain. We've created a rain drops shader, a rain drips shader, and then last week we created a rain ripples shader. And this week we're going to use those rain ripples to create a puddle. As you can see in this reference footage, after it's been raining for a little while, water accumulates on surfaces. And you can see the rain ripples as the raindrops hit the puddle. And that's the effect that we're going to create today. We're going to create puddles that are able to grow as it continues to rain, and then shrink as the rain stops and the sun comes out and things dry up. So in order to create our puddles, the first thing that we're going to do is we're going to start out with a texture sample. And this is some cloudy noise that I created a while back when we did our distortion shader. So this texture I've called distortion. And if we take a look at the individual channels, what I want to show you here is the green channel. You can see that there's just a lot of cloudy noise here. And what we're going to be able to do is make puddles that grow using this cloudy noise. So the puddle will start out at the very darkest spot and then grow as it continues to take up lighter and lighter pixels. So let's go ahead and do that. We're going to switch back here to our weather puddle demo. And the first thing that I need to do is create some texture coordinates for my sample. Now our puddles are going to be projected in world space from the top down, and so I need to bring in the world position, and we're only going to be using the red and the green channels of world position, so I need a component mask. So we're going to use a component mask, the red and the green. And this is basically an XY projection. XY because Z is the up vector. I'm going to multiply this by a small number to get the correct size units. So we're going to multiply it by 0.01. Alright, so now we have world space 0.01. And let's see what happens. I'm just going to take this, my UV coordinates, and I'm going to be using the green channel here. So I'm going to wire the green channel into color, and let's take a look at what we get. So you can see that it's really streaky, and the reason for that is that we're looking at the sides of a cube. If I switch over to a sphere, you'll see that this noise pattern is projected from the top down. So let's rotate our scene, and you can see that it's projected here to the top of the sphere. I'm going to switch this back to a cube. Okay, so we've got our noise pattern projected into our scene. And now we need to adjust the pattern a little bit so that we get puddles only where it's the darkest. So the first thing that I'm going to do is I'm going to create a constant value. And this constant is for how big the puddles should be. So I'm going to give it a default value of 1. And then we're going to create a lerp node, a linear interpolate. And I'm going to use the puddle size here as my alpha value. Now I'm going to add two constant values, and these are going to be constant vec2s. These are going to contain the measurements for the brightness values for where I want the puddles to go when the puddles are the smallest and when they're the largest. So I'm going to add two of these. And for the first one, I'm going to give it a value of 0.0001, and then the second value is going to be 0. Actually, I need one more 0 in here. And then for the second value, I'm going to use a value of 0.1 and 0.25. So these are going to control my minimums and my maximums for how large my puddle is when it's at its maximum size and when it's at its minimum size. All right, now I'm gonna use a component mask again, and this is gonna be my red, and the second one's gonna be my green. So this value is gonna be lerping between the very small 0.00001 and 0.1, and this value is gonna be lerping between 0 and 0.25. So the second values here are my maximums, and the first values here are my minimums. So now I'm going to take my texture and I'm going to subtract it from the second value, and then I'm going to divide it by the first value. And let's take a look at what we get from that. Alright, so we've got something that looks like a puddle. This white area is the area where there are no puddles, and then the black area is the area where there are puddles. So this is the maximum puddle size right now, but if I were to shrink this, let's say 0.5, you can see that the puddles are smaller, and the smaller my number gets, the smaller my puddles will get, and if I give it a value of 0, I should have no puddles at all. And that's exactly what I'm looking for, so I can use this value to control the size of my puddles. If I want larger puddles, I could increase this 0.25 maximum to something like, let's see what we get. If we give this a value of 1, and then we give this 0.25, let's give it a value of 0.5, and now we're going to get like almost all black. The puddles are actually running into each other. This is too much. We don't actually want anything to be this flooded. And so we're going to give it a maximum value of 0.25. Okay, so we have our mask, and we have a value that controls the size of our puddles. Now we're going to just saturate our value here to make sure that it stays between 0 and 1. And then we're going to invert it so that the areas where the puddles are white, and the areas where they're not are black. And that is done with a 1-. Alright, so there we go. We've got our puddles in white and our non-puddles in black. If we want to make our puddles slightly smaller, 0.5, kind of scale the puddles down a little bit. Alright, so we've got a couple of puddles here. And the next thing that we want to do is, if I zoom out a little bit, you can see that when a puddle reaches the edge, it kind of smears itself down the side. And that's bad because our puddles are being projected in the z-axis, or from the top down, and we don't want puddles to show up on the sides of things or when surfaces are not flat. So I need to create a mask to get rid of the puddles in areas where surfaces are not flat. So I'm going to bring this bit of our shader down here, and then here I'm going to create a mask for only showing the puddles in flat areas. And so I'm going to add a world space vertex normal, and I only want the Z component, so I need a component mask. I'm going to mask out the Z component of my world space normal, and now I'm going to saturate it so that I don't get negative values, and then I'm going to raise it to a power of 30. And that just increases the contrast of my mask. And just to show you what this mask is doing, let's wire this mask directly. I'm going to change this to a sphere, and we'll wire this directly into our base color just so we can take a look at it. So you can see that it's white on the top, and then there's kind of a short fall off, and then the rest of it is black. So this is going to make it so our puddles only show up on up-facing surfaces. So I'm going to take this mask and multiply it by our color mask. And now we're going to get puddles that only show up on the top, and there's no more ugly streaking down the side. That's exactly what we're going for. Alright, there's one more thing that we want to do. Eventually we're going to want to create some normals, but before I do that, there's one more thing that I want to do with these puddles, and I just want to multiply it by 1.1. And what this is going to do is that it's going to ensure that our puddles go all the way from black to white. So I'm going to multiply this by 1.1, and then I'm going to saturate it. Great. So that's the puddle mask that we're going for. All right, the next thing that we want to do, like I said, is we want to bring in our normals. Now, in order to bring in the normals, we need to use some of the shader functions that we created in previous tutorials. I'm going to bring in this weather wind ripples function. And this one I haven't shown you yet. I'm going to show you that in a minute. And we also want this weather ripples function. And this is the one that we created last week. So we're just going to bring it right in there and drop it down. And now before we go on, what I want to show you is this weather wind ripples function. The purpose of this is to create ripples on the surface of the puddle as if the wind were blowing the water. So I'm going to wire this over here into base color just temporarily so that you can see what it looks like. And it takes a wind value, so we need to create a constant here. And I'm going to pass in a 1, telling it that the wind is at full strength. So let's take a look at what we get from this. All right, so you can see that I have these normals that are scrolling across the surface. Actually, you know what? This might look nicer if I wire this into the normal socket. Yeah, there you go. So it makes it look like the surface of water. So I haven't shown you what's inside here yet. So let's go ahead and take a look at our weather wind ripples function. So I have it open here. Here's our weather wind ripples. So you can see I have 2 texture samples that are sampling the same texture. It's the T water N. And this is a texture that just ships with Unreal, so everybody can use it. I have 2 of them, and I'm using different sets of UV coordinates to scroll them, and then I'm using this method here to add them together. Let's walk through this just a little bit at a time. So just like I'm doing with the puddle mask, I'm taking my world position to project the texture down onto the surface. And I'm using the red and green channels of world position again. And I'm putting red and green into the red and green channel here, and also the blue and alpha channel here. So now I have 2 sets of my UV coordinates appended together. So I have red and green, and then red and green again. And then I multiply those by this value here. And what this does is it scales our world position so that the ripples are the correct size that I want. So my first set are multiplied by 0.018 and 0.013. And then my second set are multiplied by 0.007 and 0.017. So that will scale my coordinates. Then I've got time here, and I'm multiplying time by 0.4, 0.02, negative 0.1, and 0.4. And this is controlling the way that the coordinates are scrolling. So it controls the speed and the direction of scrolling. So I add my time, and then here I combined the red and the green, and here I'm splitting them up again. So I take the red and the green as my coordinates for my first texture sample, and I take the blue and the alpha as my coordinates for my second texture sample. Then once I've sampled, I use this append node to put the red and the green channels together into a single unit. And the same thing down here, the red and the green channels into a single unit. And then I add those together. Now here, I'm multiplying the added together red and green channels by wind. So this is the wind speed. So I saturate it so it isn't allowed to go below 0 or above 1. And then I adjust the range so that it goes between 0.2 and 0.5. And then I use this value to multiply my normals. So what this is doing is it's controlling the height of the normals. So when the wind is not blowing, my little ripples are at 0.2, and when it is blowing, they're at 0.5. If I wanted ripples to be stronger, I could increase this 0.5 value, or if I wanted them to be like non-existent when the wind wasn't blowing, I could set this to 0 if I wanted to. So that is my control that controls the strength of the normal based on how hard the wind is blowing. And then, so I've multiplied my x and my y coordinates by the scalar value here. And then I'm appending the z component of the normal, which is here. I'm adding or multiplying the blue channels of the normal map together and using an append. So the result of this whole function is that I have these normals that are scrolling across each other and making it look like the wind is blowing the surface of the puddle. So that's pretty cool. Now the next thing that I need to do is take my weather ripples normal, and this is what we worked on last week. Here you can see that this function that we created takes in an intensity, the intensity of the ripples, and it also needs UV coordinates. So for the intensity, just for now, I'm going to wire in this 1. And for the UV coordinates, we actually want the UVs that we've created over here. We're going to project the ripples in world space from the top down using this multiply. So I'm going to wire this world space UV coordinate into the UV socket of my weather ripples function. And then let's take a look at what these ripples look like if I wire them in as the normal. Alright, so you can see this rain ripples pattern that we created last week, and it's pretty cool. So let's take the normal result from the wind ripples and the normal result from the weather ripples and add them together. So we're going to add these two normals together, and then we're going to just mask out with a component mask again, and then we're going to create a normal by appending a 1. And if I wanted to here, I could take the blue channel of these and add and multiply them and use that as the z component of the normal. But in this case, I'm going to save just a little bit of math and just use a value of 1. Alright, and so let's see what happens when we use this as our normal. Nice, so you can see I have the ripples scrolling across, the wind ripples, and they're combined correctly with the rain ripples. But this still isn't quite right because right now I've just got like the whole world is a puddle, and that's not exactly what I want. So I need to incorporate the puddle mask that I created. So in order to do that, what we're creating here, we've created a material, but what we're really creating is a function. And so I need to be able to combine this puddle with whatever the normal is on the surface. Eventually, I'm going to be adding these functions to any other kind of material. So if I have a rock material or a wood material or whatever kind of material I have, I want to be able to apply this function to it so that it can look like it's being affected by the weather. And I want to be able to take this puddle and blend it with whatever the normal of the surface already is. So in order to do that, what I'm going to do temporarily is I'm going to create a constant vec3 and this vector is going to represent the normal of the surface as it is now. So I'm just going to make it 0, 0, 1, which is a flat normal. And then I'm going to lerp that with my puddle normal. So these are the normals of my puddle. This is the normal of my object. And then I'm going to use my mask to blend between the normal of my object and the normal of my puddle. So let's use this as our normal now. And you can see that I'm only getting my animated normals in the area where my puddle mask is. Now remember, if I wire this in as my base color again, you can see that the puddle mask only shows in these specific areas. Now it's pretty evident now that we've got our normals blending in here that our puddles are kind of the wrong size. And so what I need to do is go back and adjust the size of my puddle texture projection here so that I'm getting puddles that are larger, because when we take a look at the way the normals look, The normals are the correct size, but the puddles are teeny tiny, and that's just not what we want. So I'm going to add another multiply here, and I'm going to multiply my world space position by a value of 0.03, and we can use this for now, but you can adjust this value to whatever you want depending on how big you want your puddles to be. Alright, so now you can see that I've only got a puddle that's here on the surface, but it's more of a realistic size. So, super cool. We created a shader that generates puddles, and I can control the size of the puddles with this value here. So I can shrink them and grow them. And I can control the intensity of the rain ripples with this value here, and I can control the intensity of the wind if I actually have a different value. There we go. So wind control, rain ripple control, and puddle size control. And now what I need to do is take all of this and create a function out of it. And I already have, so let's take a look at that function now. Alright, and by the magic of editing, I instantly have a function that's a copy of the shader that we just created. So you can see how I've created an input for wind, an input for rain controller, an input for the puddle size controller, and an input for our normal. So let's go ahead and take this function and apply it to a material and see what we get. Alright, here you can see I have a wood material, M wood oak. And I just duplicated this material that comes with Unreal, and I added the puddles name at the end of it. And I've brought in my weather puddles function that we've been creating. You can see I have inputs for wind, rain, puddles, and normal. And so what I want to do is go ahead and hook this up. So here's the normal from the wood planks, and I'm going to wire these into my normal socket. And then I'm going to wire this normal out to the base normal. Now it's giving me an error because I don't have wind, rain, and puddle values here. So I'm just going to go ahead and create a constant of 1 and wire that into my wind, rain, and puddles value. And let's take a look at what we get. Cool, it's kind of subtle, but if you look at just the right angle, you can see that there's a bit of a puddle happening here. Now, the reason that it's subtle is because I'm not using the puddle mask correctly. This is our mask here. And what we're going to want to do is use this mask to blend between the standard wood values and the values that I want to give it. So you can see here we've got a base color, a roughness, and a normal. So let's just go ahead and add a linear interpolate, and we'll use our puddle mask. So where there are puddles, we're going to want it to look wet, and where there are not puddles, we're going to want it to stay looking the way that they've got it. So this is going to be our roughness. We'll wire the roughness in here, and then we'll just give it a constant value of 0 for roughness for when the puddle is in that position. So we're going to use this as our roughness. And that should give us a pretty nice looking puddle. Yeah, there we go. So we've got a smooth looking puddle and then a dry area over here. So that's working pretty well. Nice. So you can see that the puddles have wind ripples and they have rain ripples. And I can control all of these features independently. So if I duplicate this value, I can tell it, well, actually, I don't want it to be raining, but I still want the puddles on the surface. So I'll give this a value of 0, wire that into rain. And now I'm not going to get the circular rain ripples, but I'm still going to get the puddles and the wind ripples. That's pretty cool. Now if I want to tone down the wind a little bit, I can wire 0 into that. That's going to make the wind ripples a little bit softer. And then I can use this value here to control the size of the puddles. So if I want a really small little puddle, I can maybe give it a value of 0.2. I don't know if you're going to even be able to see these. Yeah, they're already gone. So yeah, here we've created a function that allows you to add puddles to things. Now, if you'll remember, in previous weeks, we added drops and drips and wetness. So now we have puddles, and we have all the elements that we need to create a really cool weather system. So in next week's video, we're going to take our puddle function, our drops function, our drips function, and our wetness function, and we're going to combine them all together to create the complete weather or rain function that I know that you've all been waiting for. So be sure to subscribe to the channel and tune in next Thursday, and we'll go over this really cool combining of all the weather effects. Thanks for watching. We'll see you next week.